So goal. So let's move again into topic 4. Goal of it's advanced visualization. Yet another application I want to show for you compared to previous MJ. As I already mentioned, this application has name MevisLab. Developed in German Institute of Fraunhofer. So here is given a link to download an explanation how to pass through some panic information preventing tools, how to run it even on Mac OS. So here is we have solution Linux, Mac OS, and Windows. Any platform, not phone this time, of course. It's quite large. 1.5 gigabyte, a very large application, and have some demanding requirements. Anyway, it's provide very interesting features and capabilities for working with images. Let me show for you this example. The idea of this application is usage of, let me put this into view. It's use visual tool, visual blocks. Where is this? Here. If you want to do something in MevisLab, you have to create this. These things you see on the screen. It's called mesh in terms of MevisLab or diagram of processing or workflow. Actually, all operation in MevisLab bundled into so-called blocks, and each block performs some one major operation and have some additional extra features, but one major operation. And as a result, when you want to do something, you have to assemble mesh which consists necessary blocks, join those blocks with data transmission lines, with those arrows lines, and you will get what you need. For example, if you want at least visualize image, so here is user interface, how it's look like. Now we're moving to it. How to search and add the block. I will show this. Block properties. But for me, interesting next point. So here is, if you want even just visualize image, you need at least two blocks. One to load data, and second to visualize it. Connect it, and you will see something like this. If you want to, and you can achieve two-dimensional as well as three-dimensional visualization. To three-dimensional visualization. So, of course, you will need to download necessary image. Let me do this first. Here is, I have this image. I will place into my computer. I have to uncompress it. Yeah, something like this one. Good. And let me start MevisLab from my computer. So here is, we have multiply application in this bundle, and I need this one, MevisLab 0.4 or just MevisLab, just this thing. Quite minutes for loading. Again, it's application developed by medical scientists and dedicated for medical scientists. So it's a little bit look like some development tool, and it is, in fact, you can even create your own application in visual way, so you can save it as standalone application. Right now we already have empty mesh and we have to add our blocks, modules available in the modules menu. There is plenty of them. It's like 3-4 level menu to like here is how many levels do we have to get our modules. But if you know module name and you will now from this instruction you are given all necessary names. So just type this name and in search bar, and you can add it in one click into your system. Like visualization, empty because we don't have data to visualize. So we use image load. Image load to get our data. And here is, again, nothing there. So I browse to my image. Where I have downloaded from Moodle. Under downloads, I have plenty of different things. Yeah, here it is. DCM image, of course, you have to yes, it's loaded, but like we have nothing to show because this tool only access data container. Anyway, you can make preview. If you click container, it will give for us something. Wheel of mouse button required to scroll to if you have stacked image, and this is one of this. So to make visualization, I just click connector and join it to two-dimensional viewer. Click, hold, drag. Or click, hold, drag outside to disconnect. Or again, click, hold, drag. And now I can review it in view mode. And I can use my mouse wheel to navigate, right mouse button to adjust brightness, contrast, and so on. And if I want three-dimensional visualization, like it's shown, it's the same picture. So here is it. I just added one more tool, one more block, three-dimensional viewer, connect to the same source, and I got this. So here is we have so-called pseudo three-dimensional image. I can also adjust brightness, contrast. In this case, it will work as transparency. I can move around. So that's all out of the box features. You can check your own features, and with escape you can even make your additional cross-section and so on. So here is that's built-in viewer how it's work. I'm back to task. If I back to task, it's also actually I provide for you solution for this part. Then contour filter, just a little bit would be better for you to create another mesh, but I will show some parts of this in this case. So here is in this case you have to create filter which will provide which will make some selection of image and demonstrate borders between of tissue with different type of tissue with different characteristics. So in this case, we need these elements: convolution, morphology, and arithmetical analysis. Oh, we have daily routine in the Ukraine, civil defense siren, which indicate potential aerial attack. So anyway, what should I do? Continue. So let me add the few those blocks here. convolution, morphology, and there is few arithmetic blocks, so you need, they implement different features. Please use proper. So convolution, and let's connect that way they are, how it's described in task. Convolution morphology, okay, let's that way. Arithmetic, yes, input. We need one more two-dimensional viewer. And I connect it to the output. And I need some extra settings, like I have to same geometry for all three axes, 3 points, and I have to use subtract. I want to have difference between this dilatation and transformed images. So, and right now my filter already ready. So I just use some adjustments. So here is. Here is the 6. Okay. Here is already working. Actually, it's a little bit incomplete. It's a little bit incomplete. Thus, you have same step-by-step instruction how to achieve all this. Sure, you need to ensure that you use proper settings. Yeah. You also have to create a sync between images. Here is explained how. I will omit this for now. And even more complex mesh you have to create in your chapter 5. So 3 tasks: minimum visualization, region filter, and regional filters. All this, that's your task you have to complete. Of course, not when you complete, not forget to save your results. 2. So, okay.